All right, so today we are going to continue our transformation of the graph unit. We had initially introduced the parent graphs of 6 basic functions, and then we played a little bit with Desmos and looked at transformations of the graph. To be more specific, we applied horizontal shifts and then vertical shifts. Let's go ahead and take out those notes. So gentle reminder. So our horizontal shift is given by the form f of x minus c, where if c is positive, then we're going to move so many units to the right, and if c is negative, then we're going to shift so many units to the left. Vertical shifts, on the other hand, are given of the form f of x plus c. So if c is positive, then we're going to move so many units up. Oh, I just realized that I didn't put positive before. This is why you're supposed to sleep. Okay. So if C is positive, we are going to move so many units up, and if C is negative, then we are going to go ahead and move so many units down. But now it is time to give Desmos a break, and it is time for us to sketch these transformations by hand. Bear with me. Okay, so fun problem number 1. Oh, we haven't seen those words in a while. It says the graph of f of x is given. It says graph the following transformation. Then write the equations of the parent graphs and the equations of the new graphs. Okay. The thing is, what should we do first? Should we graph the transformations, or should we write the equation or function first? That's a personal choice. No one's gonna know what you did first. In this case, I'm going to apply the transformation first because I want to focus on the notation versus me giving you the equation. So we are asked to, so on the left side we have the graph of f of x, and we are asked to graph f of x minus 2. So a gentle reminder, horizontal shifts are given of the form given by the form x minus c. Okay, so if c is positive, then we're going to shift to the right. But if c is negative, then we're going to shift to the left. So in this case, the number that follows the subtraction sign is -2. The number that follows the subtraction sign is +2. So in this case, c is +2. So we're going to go ahead, take our parent graph, and then shift 2 units to the right. I'm going to go ahead, take these points. So the first one is where x equals 0, so that will be 0, 0. And we had said that the transformation is that we're going to shift to right. So shift to right. So if I'm at 0, 0, we're going to shift to right. And then if I really wanted to do a very rough sketch, then I would do my parabola here. But I want to have a nicer sketch, so I'm going to go ahead and apply the transformation on 2 more of those points. So the next ordered pair that's highlighted is 1, 1. And then the transformation is 2, 2 to the right. The next one that caught my eye is -1, +1. I don't know how to count. So we're at -1, +1. And we had said the transformation is to right. I think that's enough in terms of being overachiever. We have 2 more points that are highlighted, but I'm okay with that. So we are on track to earning our full credit. Okay, pretend this looks pretty due to human error. So what is the equation of the parent graph? So you can write an equation, so you put y equals, or we can stick with function notation. Ask your instructor. Okay. And then equation of new graph. So the parent graph is x squared. Okay, we shifted 2 units to the right, so horizontal shifts, we're gonna do x minus a number. We shifted 2 right, so we're gonna put a +2 after the subtraction sign, and that will be our answer. Okay, if this is a lot of information for you, then this is how we're gonna go about it, which maybe I should have started off like this. Okay, so the graph the graph of the parent graph is at left, and the transformation is f of, where am I, f of x minus 2. So what we are gonna do, we are gonna substitute the x minus 2 for the input of x. Okay, so we have x, which we are swapping out for x minus 2. And what is going on with that x? It is being squared. Cool, but let's go ahead and write it without that notation. Perfect. All right, so let's go ahead continue the fun with problem B. Problem B, so we have the graph of f of x. Just go ahead, pencil in the equation. So this is the absolute value. So we have f of x equals absolute value of x. So again, we can write down the equation or function now, or we can do it later. And we are asked to graph f of x plus 2. So remember, horizontal shifts are given of the form f of x minus c. So in this case, what we are changing is the import of the x value. So I know we're going to have some sideways action or horizontal shift. But the question is, I know there's a 2 involved. So my dilemma is, are we going to go 2 right or 2 left? My eyes tell me, look, we have a positive 2, so we want to go 2 right. But bear in mind that horizontal shifts are of the form f of x minus c. Last time I checked, this is not minus something, so we're gonna have to force a subtraction. Okay, so if we force a subtraction, this will be f of x minus negative 2. Okay, so opposite of addition is subtraction, and opposite of positive 2 is negative 2. So the moral of this story, adding 2 is the same as subtracting negative 2. So now the question is, do we really have f of x minus a number? We sure do. So in this case, the number that follows the subtraction sign is negative 2. So that will give us that c equals negative 2. And if c equals negative 2, then that means we're going to shift 2 to the left side. So in terms of doing a sketch, that's very easy. We just go to left and we take it as such. Okay, but we want to have a better graph. So let's go ahead, take a couple of these points. Well, I lie. Let's take at least 3, and then we'll apply the transformation, which is to left. So the one at x equals 0, or the origin. So so we're at 0, 0. We go to left. The next one, I'll take the one at 1, 1. Here's 1, 1. We go to left. And then this one, I want to say is negative 1, positive 1. Negative 1, positive 1, and we said the transformation was to left, and that looks this looks just as good as our quick sketch. Cool. All right, so we have 2 problems down, plenty more to go. Well, not plenty, we're doing a total of 5, which seems like a lot, but it's not that much. All right, so moving forward to problem C, looks like we have the graph of, if you guessed it, f of x. Okay, to be more specific, this will be the graph of the cubic function. And although I'm pretty pumped about this graph, I just realized I failed to follow my own directions. Okay, so I was focusing my energy on the graph of the transformation that I forgot to write the equation of this graph. Okay, so we can answer this problem in 2 ways. We can substitute a x plus 2 for the input of x, or we can just keep our cool and do what we gotta do. Okay, so the graph of the parent function was f of x equals absolute value of x, and then we had some horizontal shifting. So horizontal shifts are given of the form f of x minus c. So we're gonna subtract something from the x. Since we shifted 2 units to the left, then we're gonna subtract a negative 2. And then that will simplify to absolute value of x plus 2. Cool. So sorry about that. Okay. So moving now forward to problem C. Okay. The graph of f of x. This is the graph of the cubic function. Give me a second. This segment before another little someone also wants a glass of milk. Okay, so the graph of f of x is shown on the left, and we are asked to graph f of x plus c. So the question that I'm going to ask myself is this: what kind of transformation is this? Is this a horizontal transformation or horizontal? Yeah. Are we shifting horizontally or are we shifting vertically? So remember, vertical shifts are given of the form f of x plus c, and that's because we are changing the function value, not necessarily the input. And in this case, what is the value of c? So in this case, c is positive 3, so that means that we are going to shift 3 units up. If I wanted to do a really rough sketch, I'm at 0, 0, I go up 3 units, and that's pretty much my rough sketch. The graph of the cubic function is really hard for me, so I'm going to go ahead shift these 3 points. So the first one is at 0, 0. Let's go ahead locate that, and then we have a vertical shift up 3 units, 1, 2, 3. The next one is 1, 1. Let's go ahead locate that and go up 3 units. Hopefully I know how to count. The next one is negative 1, negative 1. And then we go up 3 units, 1, 2, 3. Okay, so with tired eyes, I want to take a straight edge and do a straight line, but this does not look like a straight line, so I'm going to do my best to do the graph. Okay, that was horrible. Hopefully the instructor will have mercy on me. Okay, so the equation of this, the one that we graphed. So the equation, well, in function notation, is given by f of x equals x cubed. And what did we do to this function? We shifted vertically by 3 units. Okay, so we added 3 to the function value. So we're going to take our function and then add 3 to it. Alright, so I know you guys are excited, so don't worry, we got 2 more problems and we call this a wrap. Okay, problem D. So we have the function that we have is the square root function. So let me go ahead write it before I forget. Sometimes I get a little bit excited and just do the graph. Okay, so what is going on? We have graph f of x minus 4. So in this case, so remember, vertical shifts are given of the form f of x plus c. In this case, the value of c is negative 4, so that means that we are going to shift 2 units down. If I had to do a quick sketch, we shift down 4 units. I'm at 0, 0, 1, 2, 3, 4. And we shift 4 units down, and that's pretty much it. But we are feeling like overachievers, so let's go ahead, take 1, 2, let's go ahead, take all these 3 points and shift them down 4 units. So the first one is at 0, 0, we locate 0, 0, and we shift 4 units. I don't know how to count, 1, 2, 3, 4. The next one is at 1, 1, I believe. Let's go ahead, locate that, 1, 1, and then shift 4 units, 1, 2, 3, 4. Awesome. The final one is at 4, 2, so we go 4 to the right, up 2, and then we are shifting down vertically by 4 units, so we have 1, 2, 3, 4, and I think this would allow us to do a nice smooth curve. Are you excited? I'm excited. Are you excited about the math, or because we're just one problem shy from being done? Oh, it will make me happy if you think it's the first one. Okay, so let's go ahead, change it. We'll knock out problem E, and that will be our segment of the moment. Okay. So problem E is what I could consider the final exam. Okay, so in this case, we have more than one action going on. We are doing something to the x value, and then we're also doing something to the function value. So the graph, the equation of the parent graph, this is the square function. So we have f of x is equal to squared. We're doing something to the x. So remember, horizontal shifts are given by the form f of x minus c. I don't have a subtraction sign, so we're going to force it. Opposite of addition is subtraction, and the opposite of positive 1 is negative 1. And just like that, we force a subtraction problem. If it's easier on the eyes, you can wrap up the negative 1 to separate the subtraction sign from the negative 1. So in this case, the number that follows the subtraction sign is negative 1. So in this case, we are going to shift 1 unit to the left. And then we are subtracting 3. So then we're going to shift 3 units down. So 1 left, 3 down. So let me go ahead, do a really quick sketch on the left side, and then we'll do a nicer graph on the right. So we go 1 left. So if I'm at 0, 0, we're going to go 1 left, and then we're going to go 3 down. 1, 2, 3. I think I know how to count. and then we'll do our rough sketch. But oh, that was horrible, but this is why we use pencil. Okay, all right, cool. So let's go ahead and do this neatly. So we're at 0 0, and our guideline says 1 left, 3 down. So we're at 0 0, 1 left, 3 down, 1 2 3. Another point that caught my eye is the one that's highlighted right here, which is 1 1. So let's go ahead and locate that, and then the directions or the transformation: 1 left, 3 down. So we have 1 left, 3 down, 1 2 3. And then it would be nice if I had a third one. So we're at -1 +1, -1 +1, and the direction, I think it was 1 left, 3 down, 1 left, 3 down, 1 2 3. And then we have 2 more points highlighted, but we don't have time for that. Okay, so we're just gonna do our best to do a nice smooth curve. For me, it's really difficult to do the graphs if I don't rotate the paper, but I'm trying to minimize the number of times that I rotate the paper. And someone forgot to cover up what we're gonna do in the next video, so I guess that's a sneak peek, but we're just gonna stop it right here. Alright, thank you guys. So we have a couple of more videos to go in the series, but I hope you found this helpful. Thanks. Bye.